Okay, you got that pretty quickly. So what I asked was, looking at this, what's the coefficient of W1? Well, looks like it's A11 times X1 plus A12 times X2, so forth to A1N times Xn, right? And what's the coefficient of Wm? Well, AM1 X1 all the way up to AMN XN, right? And then that's times WM. Okay? Well, isn't this coefficient just the product, and I didn't leave myself enough room to write it, but I'm going to write it anyway. Might be a little hard to read. I'll try to rewrite it on the next board. Isn't this just the row A11 through A1M multiplied by the column X1? It's A1N, not A1M. Can't read my own writing. That has to match up, okay? This row times your X column vector, right? And I can write this one out just a little better. I have a little more room. And the last one is AM1 AM2 through AMN times your WM, and the arrow is supposed to be over the W, not the M. And of course I've got W1 here. Okay? That makes sense? Can you see that? Pattern's pretty clear if you look at this. I didn't write it out real well, but hopefully you see it. Okay? So what do we do with this? This vector this vector is going to be represented by a column vector. Column vector is just going to be this, because this means first element of this means we multiply this by your first basis vector, W1, right? Okay? Well, that equals this, doesn't it? First row times first column gives us first row times first column, right? Second row times, well, I have one column. Second row times our column vector gives us second row times our column vector, right? It expands like this, but this is what it means. Okay? So in terms of bases, B, and I still want to use B and B1, it's really B prime, right? And then this is the matrix representation. Okay? And just kind of summarize all that. That's the details. Oh yeah. Not with it. Okay. Okay, so again, we have a transformation from B to W. Relative bases V1 through Vn, and that N just looks a lot like an M. Got to sand these boards down. And W1 through Wm for the other space, right? Okay. Things you got to really understand and keep in mind is that the column vector x1, xn, and now I'm going to put a B here just to remind you that this is relative to this basis, right? That's what this column means. If I had a different basis, I'd have different numbers for my x's, right? Okay? So the numbers here depend on what your basis is. And we'll use Okay, this vector is in V, right? Because the V1 through Vn are basis vectors for V, right? And this vector is in W because the W1 through Wm are in W. Okay? That part isn't rocket science, but the rest of it kind of is. Okay? Makes sense? And again, depending what this basis is, these numbers will be different. Okay? And then this product relative to the basis B
I was like, holy shit, everybody said his.
equals y1 through ym b prime as developed represents the transformation, right? Or this vector, this matrix represents the transformation in the sense that if this vector represents a vector in V relative to this basis, then the product you get will be the representation of the vector in W to which it's mapped. Also, I haven't mentioned it, I've mentioned it in passing, I haven't written it. Since these are bases, these representations are unique. There's not another set of x1 through xn that represents the same vector. Okay? And there's not another y1 through ym that represents the same vector over in W. Okay?